Hello everyone, welcome to Techie. You ever type in a web address, hit enter, and just wonder what actually happens? I mean, it feels like pure magic, right? A web page from halfway across the world just pops up on your screen in seconds. Well, it's not magic. It's actually a really complex, super high-speed conversation between computers. And in this explainer, we're going to pull back the curtain on the very first step of that conversation, a really critical place where we, as users, connect to the digital world, the application layer.
Okay, let's dive right in. See, to make sense of how the internet works, engineers came up with these models made of different layers, and each layer has a specific job. We're starting at the very top, with the one layer you interact with every single day, probably without even realizing it. This is the application layer. And honestly, the best way to think about it is as the front door to the entire digital world. This is layer 7 of a networking framework called the OSI model. And its purpose is simple, but it's absolutely essential. It's the interface, the go-between, for the software you use, your web browser, your email app, and all the complicated network stuff happening in the background. It's the layer that makes all the network services visible and, well, usable to your apps. Without it, your browser would have no idea how to ask for a web page, and the network would have no idea how to deliver it.
So, here's the crucial part. The application layer is basically a great translator. When you click a link, you're giving a command that a human understands. This layer takes that command and translates it into a standardized request that the network can actually process. And then when the network sends data back, layer 7 translates it from raw data into the images, text, and videos that your application can show you. It's the bridge that connects our world with the world of machines.
Now here's a super common point of confusion that's worth clearing up. It's easy to mix up the application layer with the application itself. I mean, they've got the same name. But layer 7 isn't the buttons or menus you see on the screen. A much better way to think about it is like this. If your web browser is a house, layer 7 is the foundation and all the utilities, the plumbing that brings in data, the electrical wiring that powers communication. You never see the foundation, but without it, the house just wouldn't work. All right, so that brings us to a really important point. The two major networking models that pretty much define all of modern computing. They've got different structures, but they're both trying to do the same thing, make sure computers can communicate reliably. We're talking about the OSI model and the TCP/IP model. So on the left, you've got the OSI model with its 7 layers. Think of this as the theoretical blueprint, the perfect standardized guide for how a network should be built. Then on the right, you've got the TCP/IP model. It's more practical, streamlined down to 4 layers, and it's the model that the actual internet is built on today. And here's the key thing to notice. TCP/IP takes the top 3 OSI layers, application, presentation, and session, and just bundles them all into its single, powerful application layer. This table really breaks it down nicely. The easiest way to remember it is that the OSI model is the why, it's the textbook, the theory of what each layer should do. The TCP/IP model is the how. It's the real-world engine that's actually running things. See, the OSI model just defines functions, but the TCP/IP model is built around specific core protocols, and that's exactly what makes it so practical and effective. So we've established that the application layer is a bridge. But how do all of these different programs, built by different companies all over the world, talk to each other so perfectly across that bridge? Well, the answer is a set of shared rules, or what we call protocols. They are, quite literally, the languages of the network. I love this quote because it just nails it. A protocol is just an agreed-upon set of rules for how to communicate. Just like grammar makes sure we can understand each other's sentences, network protocols make sure a request from your browser can be perfectly understood by a web server, even if they were built decades apart. Without these shared rules, the internet would just be total chaos. And yeah, just like in the real world, you don't use the same language for every single situation. A network is made up of tons of specialized servers. A web server is built to speak the language of HTTP to serve you websites. An email server speaks SMTP to handle your messages. A file server might speak FTP. Every task has its own special, optimized protocol to make sure things get done right. Let's just quickly run through the big ones you use every day without even thinking about it. First, you have HTTP and its secure big brother, HTTPS. That's the foundation of the web. Then there's DNS, the domain name system. Think of it as the internet's giant address book. It turns a name you can read into a number the computer can use. Then you've got SMTP and POP3 for all your emails. And finally, there's FTP, the original workhorse for just moving files around.
Okay, but there's a flip side to all this.
Because the application layer is so close to us, and more importantly, so close to our data, our logins, our messages, our private info, it's also a huge target for attackers. And that brings us to the really crucial topic of security at layer 7. And I'm not kidding when I say it's a huge target. Get this. Gartner found that over 75%, that's 3/4 of all information security attacks, are aimed directly at web applications at this layer. And why? It's simple. That's where the good stuff is. Attackers want to steal your data, compromise accounts, and break services. And the easiest way in is right through the apps we use every day. Now, to talk about this stuff, we need to be clear on a couple of words because it's pretty important. What's the real difference between a threat and an attack? Well, a threat is just the potential for something bad to happen. Like a bug in a website's code is a threat. It's a weak spot waiting to be found. An attack, on the other hand, is the action. That's when somebody finds that bug and deliberately exploits it to break in and cause damage. And these attacks usually come in two main flavors, passive and active. A passive attack is all about listening in. Think of it like eavesdropping. The attacker just tries to grab your passwords or other sensitive info as it flies by, but they don't actually change anything. An active attack is way more direct. This is where the attacker jumps in and starts messing with things. They might modify data, pretend to be you, or just try to shut a service down completely. So what do these active attacks actually look like? Well, you've got masquerade attacks, where someone pretends to be you, maybe using stolen login details. There are replay attacks, where they capture a valid piece of data and just send it again to trick a system. You have modification, where they change messages on the way. And of course, there's the big one, the denial of service, or DDoS attack, which is all about overwhelming a server so nobody can use it. And a Layer 7 DDoS attack is especially nasty. Here's why. It's smart. It doesn't just flood the network with junk. It actually mimics real users. It sends thousands of requests that look totally legit, like adding things to a shopping cart over and over, or constantly hitting the search bar. This forces the server to use up all its brain power, its CPU and memory, until it just crashes, making it unavailable for actual real users. All right, let's pull all of this together. We've talked about what the application layer is, how it works, and how it can be attacked. So what's the big picture here? Why does understanding Layer 7 actually matter to you? Okay, takeaway number 1, Layer 7 is that essential bridge. It's what turns the internet from a cold, complicated mess of machines into something useful and accessible for all of us. It makes everything else possible. Takeaway number 2, it's all about those languages, the protocols. Every single thing you do online, from sending an email to watching a video, is powered by a specific set of rules at this layer. It's basically the hidden grammar that runs our digital lives. And the third, and maybe the most important takeaway, because it's closest to you and your data, it is the #1 battleground for cybersecurity. Remember that 75% statistic? Protecting this layer isn't just a technical detail. It's about protecting our privacy and the services we rely on every single day. So the next time you hit enter, maybe just for a second, think about that incredible conversation you just started at Layer 7. You now know it's not just a click, it's a request traveling across a powerful but also vulnerable digital bridge. So my question to you is, with that in mind, how does it change the way you think about your own online security?
Hey, if this helped you understand things a bit better, do me a favor and hit that like button. And be sure to subscribe to Techie for more deep dives into the tech that shapes our world. I would genuinely love to hear your thoughts or any questions you have, so drop them in the comments below. Thanks so much for watching.